Good morning, everyone. This is Thomas, Antoine, Maxime, and I am Lawrence. And today we will present you our journey of understanding, analyzing, and solving the Informed Sport Analytics Student Team Competition. As you can see on the slide, we are students from the Louvain School of Management, a university in Belgium. And you can also see that normally our team consists out of 5 people, but unfortunately Peter could not be here. And before we dive deeper into our results and recommendations, I'd like to say that we're very, very delighted we can present here Caesars Palace, Las Vegas. Now I will start with the executive summary. So first we recommend Syngenta to commercialize the 4 seeds at the right, because they will generate more than 1.2 million in sales, and they are the elite varieties based on our model. Secondly, we also recommend to use more business logic and to introduce clusters of locations to the selection process to reduce the occurrence of type 1 errors. And this is because, in our view, a seed does not need to perform well on all locations, but only on locations that matter. And so therefore, Syngenta should replace the process of averaging over all locations by averaging per cluster. And thirdly, and really key in our model, is that we recommend to establish a performance indicator. And this performance indicator measures the relative strength of a variety compared to checked varieties and can help Syngenta with targeting the right customer segment, with making abstract of external conditions, and with taking product characteristics into account. But we will talk more about that later. Now Maxime will explain you our team makeup.
Good morning. So before the start of our journey, we first had to get to know each other. And that's why we decided to use some project management tools. And so we firstly defined our respective MBTI types. And it turned out we have 2 different profiles. We have 2 consuls and 3 executives. And the main difference between us is that the consuls take their decision based on the impact it has on people, while the executives take their decision based on the data and facts. And so we are pretty similar in the end. And so it is great for communication, but there is also a risk of lack of creativity. But we, of course, made up for it. We also decided, thanks to the MBTI, to allocate some roles. So for instance, Thomas was the data crusher of the team, while I was the strategic planner.
Let's now move on to the second step of our process, framing the problem. And now Maxime will really explain our point of view of the objectives in the problem statement.
All right, so I will be very quick on the left graph. So basically, Syngenta needs to decide which seeds should be commercialized, and a variety goes to 3 stages. And after each of the stage, the variety is either discarded or not. And what we have been asked is to predict the potential sales volume of the 38 varieties that reach stage 3, as well as decide which seeds should be commercialized. And so before we could actually do that, we first had to refine our understanding on how Syngenta currently selects seeds. And from the webinar given by Nicholas Martin, we understood that Syngenta averages the yield of a variety across all locations, and that the average yield is a key factor in explaining the number of backsolds. So we plotted on the scatter plot on the right the number of backsolds against the average yield. And as you can see, there is a relationship, but it's not sufficiently predictive in our view. As a result, we believe this is why there are some type 1 errors. So some varieties are commercialized while they shouldn't have been commercialized.
Let's now move on to the third step, our method and methodology. And to make everything as clear as possible, we have a schematic overview of our model. And so, as you can see on the slide, the prediction of backsold is based on 2 building blocks, relative maturity and the performance indicator. And the performance indicator is again based on 3 different pillars: the cluster, the year, and the RM range. And really important in this slide is that the relative maturity and performance indicator have a direct impact on the number of bags sold, while the cluster, the year, and the RM range have an indirect impact to the yield. And now Thomas will explain you our first building block.
Thank you, Lawrence. So when we first plotted backsolds against relative maturity, We notice a parabolic relationship between those two variables, with a peak at around 2.5, where all the lead varieties are located. So this led us to directly introduce a quadratic term of relative maturity into our model. The second insight I like to draw out of this graph is that following our parabolic observation, we decided to conduct a discriminant analysis. And this led us to define 3 RM ranges that will prove crucial for the rest of the presentation, but I'll come back to that later on.
So now we can go to the second building block, the performance indicator. So as already explained, it measures the relative strength of a variety compared to check varieties. Or in other words, the percentage by which a variety underperforms or outperforms a check variety. And furthermore, we don't just compare varieties randomly with each other, but we make up for differences in clusters, in year, and in RM ranges. And now Antoine and Thomas will explain you everything about it.
So, as already said, we understand that Syngenta selects seeds by averaging the yield of varieties across locations. And we believe that this leads to type 1 errors. Why? 2 reasons. First reason is that a seed could have different yields depending on the location it has been tested on. So let's take a first example here. We have this seed, variety 103-142. As you can see, it has been tested on 86 different locations. But the yield varies greatly from one location to the other, and it can even triple from one location to the other. So using the average yield is unreliable. The second reason is that a seed could do well on average, but bad on very important locations that are really strategic for Syngenta. Let's have here a look at this second example. We have variety A and B that have been tested on locations 1, 2, and 3. As it is now, with the current selection method, Syngenta would select variety A, as it has an average yield of 30, which is higher than the one of variety B. But what if most of the farmers are located on location 2? Then they wouldn't be interested by buying variety A, but by buying variety B. And so after testing the seed A the first year, they wouldn't purchase it again the second year, which would lead to type 1 errors. So now that we understand the importance of location when selecting seeds, we wanted to include those locations into our model. The problem is that Syngenta uses 152 different testing locations, which is too much. So we decided to group them into clusters where similar varieties perform in a similar way. Let's have a look at this last example to understand this. So we have varieties A, B, and C. They've been tested on 9 different locations. Those 3 varieties are similar varieties in the sense that they have about the same RM. They are located in the same relative maturity range. And as you can see, on locations 1, 2, and 3, they all perform around 40. On locations 4 to 6, around 60, and on locations 7 to 9, around 70. So we decided to group those locations together in 3 different clusters. Now, I won't focus here on how we handled missing data, but if you have any questions after this presentation, I would be very happy to answer them. And so, using a word algorithm, this led us to construct 4 different clusters. As you see on the map, those clusters do not depend on geography, which means that the location in the north and the location in the south could actually find themselves in the same cluster. And you also maybe noticed here cluster number 5. This is because on some locations, only a very few number of experiments have been conducted. And we assume that because conducting experiments is very expensive in terms of money and in terms of time, if only a few experiments have been conducted, that's because those locations are less important and less significant to Syngenta. And so we aggregated all those less significant locations into a 5th cluster.
And thank you, Antoine, for this explanation about the first pillar of our performance indicator, the cluster. So now I'd like to go with you over the 2 remaining pillars, which are the year of the experiment and the relative maturity. So let's first focus on the year of the experiment. As you can see, the average yield across the year varies a lot but this, of course, is not due to the seed performance itself, but only to external factors such as the weather. So to make sure we abstract those external factors when comparing seed, we should compare them within their respective year. A similar analysis can be carried out with the relative maturity. Remember the RM range that I previously defined. Average yield also fluctuates a lot among the ranges, and so in order to make sure to compare what is comparable, we should compare varieties within their same ranges, since it only accounts for the seed characteristics and not for its performance. So now that you have the three pillars in mind, I'd like to explain you with a concrete example how we built this performance indicator. So let's take this seed. There are three steps in constructing our performance indicator. Step 1, identify all the key characteristics of our given variety. So this one was tested in 2011, RM 2.4, and you can see this average yield across the clusters that Antoine explained to us. Step 2, identify the key characteristics of the relevant Czech varieties that it should be compared to. So these are made in 2012. Why? 1 year later than 2011, because Baxol represents the second year after commercialization in the correct RM range, 2.3 to 3, and you can see here its average performance yield, across the clusters. Step 3, simply calculate the performance indicator as the relative increase or decrease of a seed regarding the Czech varieties.
Okay, let's take a step back now and use a global view again. So we just explained to you all our business reasoning behind our model. This is of course also backed by some strong math, as you can see here there on the slide in the right box. And furthermore, our mathematical model follows the same structure as our schematic model. So it's also based on the two building blocks. And as you can see on the middle box, the parabolic function refers to the relationship between bag sold and relative maturity. And the third box refers to the relationship between bag sold and the performance indicator on the different clusters. But you can also see that you have to discard cluster 1 and cluster 5 because they were insignificant. Now we can move on to the results and recommendations. And I would like to start with the left graph, where you can see the value of the performance indicators of the 5 elite varieties. However, it's clear that the last variety performs way worse than the other 4. So therefore, we discarded that variety. And then if you move to the right, you see the prediction of the bag sold based on those performance indicators. Now, the strengths and limitations of our model. So really what we want to highlight, the biggest asset of our presentation and our reasoning is the business sense behind it. So every parameter in our model is based on some thorough reasoning, and so therefore we used clusters, RM regions, and year. And so in the end, our model gave an R-squared of 39%, but we believe that our reasoning makes up for that, and also it's real-life data and no academic example. We also have some limitations. First, our model is based on a limited amount of data, and secondly, we face multicollinearity. Now we can move on to our last slide, where we retroactively tested our model on the historical data. And as you can see on the graph at the left, there is some unexplained variability. And this variability can be caused by external factors such as legislation, weather, marketing. And our model can be a tool to investigate these factors. And lastly, we've also seen that 3 out of the 4 elite varieties are from the same family. So we also suggest looking further into families and maybe also replication number. So now we have come to an end of our presentation. We have learned a lot, enjoyed it a lot, and thanks for your attention. Now